Greetings, everyone. My name is John Pulley. I'm the Senior Editorial Manager for Custom Publishing at FCW. Today's webcast, Mainframe Makeover, is brought to you by FCW and sponsored by MX Group. Presenting today's program are a pair of accomplished professionals who have deep IT experience in the public and private sectors. Frank Konechny is the Chief Technology Officer, Office of Information Dominance, and Chief Information Officer in the Pentagon's Office of the Secretary of the Air Force in Washington, D.C. An experienced systems analyst and chief programmer, Frank has supported a spectrum of government projects including ballistic missile defense, network design, missile test analysis, radar systems analysis and simulation, as well as operations research and statistical analysis. His primary responsibilities in his current role are advancing the technology landscape of the Air Force, including development of the technical target baseline, mobile enterprise solutions, data management, identity and access management, cyber and technology innovation pathfinders, and advancing the joint information environment. Danette Bayman is a solutions engineer at Micro Focus. She has worked in the IT industry for many years to help IT organizations find solutions to challenges and meet mission demands. Danette has worked in mainframe development, consulting, support, sales support, services, and management. An experienced coder, Danette has developed products in many different languages, including Assembler, COBOL, RPG, JCL, Kix, and others. In her current role, Dana is something of a teacher and ambassador who helps customers understand mainframe modernization. Now, before we hear from Frank and Danette, let's take just a moment to set the table. As we all know, the IT landscape is undergoing seismic changes that are rearranging ground-level reality as we have known it. Above, things are changing too, as emergence of the cloud reconfigures basic notions about IT networks. Yet, as the IT world evolves, the complexity of existing business applications and the environment that grew up around those technologies can limit the potential for innovation. Taking mainframe applications forward and making them a component of this nimbler new world requires new approaches. Mainframe modernization isn't the most talked about IT topic, but perhaps it should be, because incorporating mainframes into the IT ecosystem is fundamental to achieving many of the current Office of Management and Budget mandates. Failure to update mainframe-based legacy systems will impede agencies from being able to consolidate data center environments, move to the cloud, share services, or adequately enable the mobile workforce. In many cases, mainframes are the foundation for important missions across government. The question is, what does a mainframe makeover entail? What are the options, and how does an agency make the best choices? Now, before our speakers enlighten us on all of these topics and begin wrestling with mainframe makeovers, let's quickly review a few housekeeping items. First, if you'd like to enlarge the slides, look for the square icon in the top right corner of the slide window. You can also view the presentation in full screen mode by clicking the squared arrows icon. If you would like to submit a question at any time, just look for the questions field to the left of the slide window. Type in your question and click on Submit. We will field those questions at the end of the presentation. If you have any technical difficulties during the session, look for the yellow question mark icon below the slide window. Click there for technical assistance. If you would like to download a copy of today's presentations, just look for the Resource Center just below the question field. And finally, within the next day or two, we will email you a link to the archived version of this session so you can view it again or share it with a colleague. The on-demand version of the webcast will be available for 90 days after today. And now, without further delay, Frank Konechny.
Thank you, John. What we're going to talk today about is what we refer to as mainframe modernization. You know, and we all have mainframes. I mean, we used to have mainframes. The Air Force has lots and lots of mainframes. We still utilize them heavily. Now, this is interesting because we have an initiative to actually move everything to the cloud. So let's look at, going forward as what are our real problem spaces and, the options that we have to do this. First, as I said, we have many, many applications, more than I want to talk about, really. They're written in COBOL, PL1, Fortran Basic. There's some written in Jovial and some other stuff as well. And so it's really weird that after 20, 25 years of writing applications, we're at this point in our evolution right now where we have to say, guess what? The mainframe is probably not the best platform that we have to work with right now. We want to move to a more virtualized environment because we want the resiliency of that virtualized environment and the ability to take in surge capabilities. So it's really complex for us. Now, in some cases, you're not going to have the original source code, or the source code may be changed in what you thought it would be, because configuration management in the old days is not the same as configuration management today. So many source code things would change because they have to be fixed, and therefore you're not quite sure what you have. So sometimes it's difficult to figure out what you have. Sometimes you only have binary files. And so you have to understand that when you go forward, that this may be a real problem. Again, documentation is not there either. Documentation has always been a problem, especially since I used to be a coder. We never liked to document anything. And I'm sure if you guys were coders, you felt the same way. Everybody said, well, document in place, And we're always too busy actually doing the code and making sure it worked and delivering it to the customer. So, and then on top of that, test documentation is probably not existent. I mean, it happened so long ago, the tests were run, and a lot of tests are superficial, especially for changes as to what the change actually was, as opposed to testing the entire application again. And lastly, we have lots of database configurations. We went back and we had, DB2 was interesting, but we had, index file structures as well as everything else. In fact, some database systems that are no longer supported by anybody anymore. And so therefore, we got to look at, what's the real problem actually going forward with this. Now, you got to remember, applications are essential to the mission, but the underlying logic of the application in many cases is totally unknown or inaccurate. And so let's look at what choices we have. Basically, there's three. We can assess the functionality and move it into a new capability, more like a software as a service capability. That may be interesting, but there's some problem spaces that you got to consider right at the outset. First of all, you're going to have to retrain the personnel in the new system. Now, obviously, you cannot get the same user interface that you probably had with, Kix and some other stuff. You're probably going to have to understand that's going to totally change, and therefore, personnel and culture will have to change with it. Also, the question becomes, how do I know that this new solution meets current capabilities? Since I don't really have a good idea of the code, I'm not really sure, what the test cases were before. So there has to be some work done to actually validate that this code, the new SaaS capability, actually meets the requirements of the current capability. Now, in some cases, you don't want exactly the same. And so part of the analysis that we're going to talk about is how can you change that to actually do more advanced capabilities and talk about cybersecurity and embedding more security items within the code itself. Now, the second choice is you can transform the current application. Now, you have your choice here. You can actually rewrite the entire application, which is kind of interesting, depending on the size of the application. But again, depending on the complexity, to extract the business functionality and redo it may take more time and effort, so you have to put that into the equation of what you really want to do. Also, on the mainframe, there was lots of library functions that we used to use. Well, understanding that these have to be migrated and or replaced by other functions. And then there's a third choice. You may not move everything. You may rehost it. You may rehost a part of it, rewrite a piece of it, or a combination of rehosting and rewriting. It all depends upon, as you do the analysis, what you come out with. And we'll talk about those analysis steps that you have to go. Lastly, you can sunset it. You can say, I don't need it anymore. I have another application that I'm going to move this information into, and that's going to be fine. Or you decide, this is too old. We have better ways of doing things. We're not going to bother anymore. And those are the three choices that you have to make. And usually this goes back to the portfolio manager of what the portfolio manager wants to go forward with and what you've done already in terms of new functions and capabilities you want to put into the system. Okay, moving along, let's look at the business areas or the areas that you have to do for analysis. First, the business logic. This is kind of interesting because, when we wrote the code, we wrote it in all sorts of different ways, and the business logic is what is actually going on in the code. There's program structures, a lot of times there's subroutines, a lot of times there's functions, a lot of times there's very big sections of code that we write Sometimes it's very little sections of code. And so it depends upon the style of the programmer and actually as to how they wrote the code. And having been on multiple code projects and you have multiple people writing it, you'll find you have multiple versions of code structures within the same application. Also, the user interface is important because the user interface is the doorway into the system, at least from the user viewpoint it is. And that's the way that the user actually looks at it. This is what I have to do to get my job done. But that doesn't mean that in the back end of it, that's really what's happening. A lot of things manipulated in the back end. So we're going to talk about that too. Data structures. Between on the database and everything else, remember, everybody has internal data structures associated with the systems that they develop. So not only do you have to worry about databases and data files and everything else, there's also the structure of configuration files, reference files, and everything else that's associated with actually doing the business. For instance, if you have a big inventory system, you're going to have a list of parts that are someplace and a list of activities associated with that. And sometimes parts of them end up in tables, data files associated with it, and that's part of the data structures. Obviously, you're going to have control structures, control flows, our favorite if-then else statements, that goes out there forever as to, what do you want to do for control flow. And also, the interesting things about, backing out of loops instantaneously when an error occurs or an event occurs that you have to manage. So that's one of the things that you have to consider. The data flows are there too. Where's the data flow? And we'll go into more details of where it flows because data flows all over the place based on the control flows. Sometimes they go into the data structure, sometimes they go to the screen, sometimes they go someplace else. So that's a question of looking at, data flows. Lastly, we always want to have more security. This is one of the issues that we have. We have some at the mainframe level. Now, that security models are, 20 years old. Now, some of them are okay. However, as we progress into a more sophisticated environment where we have more cyber threats and more capabilities of actually getting our systems broken into, we have to look at what new things have to be added if we want to do this. Either it comes part of the software as a service solution, or it comes back as part of the transformation that we want to do, either totally or in part. Now, to do this, obviously, this is not only manual effort. You're going to have some automated tools to support. There's lots of automated tools out there. We'll go into some of the capabilities that you're actually going to need to actually do this. But remember, you're going to have SMEs. People are necessary, and you have to work with the people to actually get this done. And as we go forward, you'll see it's obvious that your SMEs have to be involved in the analysis. The SMEs are the only one that knows what's really going on. The users are the ones that have been doing this for years, and they know what's happening. At least they think they know what's happening, at least from their viewpoint. And that's necessary. But as you progress forward, either when you go to a software as a service or you do a rehosting effort or total migration, you're going to have to get the SME buy-in as this is the system that they want to go forward with. Because what you don't want is the user community hating you. Because they'll just pick your new solution to death and you won't get fielded. Now, as you do this, you got to remember some things too. The old code is still running because you can't just instantaneously convert to new code. So if you don't get the SMEs and the community in behind you to actually do the work, they'll keep on running the old code forever and keep on making excuses that they don't want to switch, unless you have a very strong management philosophy if they were going to push it through. But then, they have people leaving. And that's one of the problems we have right now, obviously, because SMEs have been there for a long time, and you don't necessarily want all of them to leave, or any of them to leave, as the case may be. Okay, business logic. You can derive, the initial business functions from the user interface, from the screen flows and the reports that are generated. This is what the user actually thinks is the business functions. Now, in actuality, you really need to map code to these business functions. And again, code may be a subroutine, and then remember, subroutine calls may be called by multiple business functions, but have different logic branches. So you may go to a subroutine that has, 5 different capabilities to it, but it may not be obvious unless you look at the code itself. Now, being an efficient coder is exactly what you want to do. You want to have one subroutine that has multiple business functions associated with it that confuses everybody when you actually look at it, because that's the way it was easier to code. Instead of putting 5 functions out there, you put one function that does 5 things. This is interesting, but that's the way that a lot of the code was written. Subroutine calls that do not appear in the application occur for library routines, or in worst possible case, operating system functions. So you got to dig farther into what is going on, what is the actual function, and where is the source of that function. And I remember when we used to do libraries all the time, and we got them part of the mainframe. So the question is, what are you going to do with them? You got to make sure that the capabilities currently exist in the new functions, or you have to rewrite them. Thirdly, if you only have binaries, what you're going to have to do is decompile them to some code base. It could be a C++ code base or something else, and look at the function and try to figure out the function. This is probably the worst possible thing you have to do. If you have binaries, it's really hard to figure out what's really happening. You're going to have to look at some interpretation as to what really, with the SMEs, as to what this really means is happening. If you're lucky, it's actually related to an input-output screen, and so it'll be easier to figure that out. But sometimes, if it's back off this function, it's going to be really hard to figure out what's happening to it. And then there's some other things at the back office. There's JCL, there's time or event-based functions like data backup. That is not necessarily obvious from the user side, but you have to include these back office functions in the actual design and analysis of where you want to go. So try to remember, there's front-end functions and there's back office functions. Next is data structures. And we kind of talked about this a little bit, but the data structures, it depends on the database you're actually using. I mean, we've had hierarchical databases, relational databases, index vSAN files. We've had a lot of structures out there. COBOL has a lot of structures within itself that you have to consider when you do things. And there's also the question of what is being initialized and what is not being initialized in these structures. All these transform into, your data logic behind the business logic. Data transformation decision regards what are you going to move? Are you going to move reference files? Are you going to move historical data? Are you going to move current data? Now, this is a big decision because a lot of times if you migrate something and you change the structure or you want to go to a more relational database, the question becomes, how am I going to move all my historical data into this new system in a way that makes sense when they do the analysis or when the reports come out? Sometimes you have to do this because a lot of times it depends upon the historical data. So you have to look at how much time you're going to look at what are you going to actually move or not move when you go to a transformation. Same with SAS. You probably will not be able to move a whole lot of SAS, but there is ways of doing this. I mean, I've been on several projects where we spent a very long period of time, and I do mean a very long period of time, writing code to actually move data between an old system into a new, modernized, reformed system. And a lot of problems you run into is some of the data historically is bad. So what are you going to do? You fix the data, you try to bring it into the new structure when it's wrong, and some new structures won't accept that. So, it's a question that you got to look at going forward as to you're probably going to spend lots of time in data transformation if you have to do it. So a lot of times you just want to move current data, which means data that I'm currently processing so I don't have to move a whole lot of information. That may be okay, but then again, you may have to figure out how you're going to manage correlating with historical data, especially if you're trying to do trend analysis and some other activities associated with that. And depending on the system, you may have to have historical data if you want to if you're doing cases for a particular person, you want to see all the historical data associated with that person. You have your choice of either moving it outside of the new system into another database or another data area where you can actually extract the information and merge it together, or actually moving everything into the new application. Again, data structures, may be desirable in a new migrated environment, but you have a lot of work involved with it. So you got to think about this as one of the major areas of work that you're going to have to move, because people don't think that. I mean, people mainly say, I'm going to move the code and it's going to work fine in the other environment and I'll move the data later. And it doesn't work that way, unfortunately. It takes a lot of work to move the data. Okay, let's talk about control flows. Now, we talked about KICS, we talked about JCL, everybody put lots of information into JCL, into KICS, and assumed lots of things were going to occur, even opening databases, access controls and everything else. So it's a question of how much control flows can you establish out of what's happening already, what you have. There's internal control flows, which is program logic, but it's really everything around that made the application actually work within the environment. And when we use kicks, we use some other things as well as to how we actually make kicks work so it worked for us in a transaction flow. And that's totally different now. Well, it's not necessarily totally, but it's very different from the web versions that we talk about doing sometimes because of the transactions change. There's subroutine calls, there's OS calls, and you have to worry about, of course, the parameters that you're passing in the subroutine calls, especially in the old days when you can overload a parameter. So you got to be careful when you do the logic to look at overloading a parameter calls and everything else so that you know exactly what is happening with when the OS. Also, there's printer and other external devices. Now, I'm sure our old code basically was using tape drives and everything else. So all those calls, get rid of them. You have to figure what you're going to do with them now, because sometimes you wrote the tape. Sometimes you wrote the tape as a intermediate media to store information before it's processed. So you have to think about, what was the logic behind this to support what the application actually needed. Now, if you're also lucky, it's in the mainframe, sometimes you have to do overlays of code, overlays of binaries. You probably don't see a whole lot now in the mainframe because they got pretty big. But initially, when we first started, we had to do multiple overlays of code, and therefore it got very confusing as to what the parameters were and what the data was. But you probably don't have to worry about that too much. And then you will probably have to assess what you always like is abnormalities in the control flow. What I always like is code not used, or branches that cannot be executed. Because remember, when you're building code, you're putting things in there. You may decide to change because that option is no longer available. I'm just going to leave it there because it's never going to show up ever again. The code may be there. Branches that may not be executed the same way. If then else, if I expect this code to occur, I'm going to do this. Again, the code will never occur because it's not one of the options anymore. Now, a lot of times, those options are in reference files or in database files, and the database files and the program logic stopped them from occurring anymore. Now, understanding that is very important when you do the control flows and figuring out what you're going to go forward with, because a lot of times you may push code out there that has a lot of abnormalities in it, and you may just assume that's really cool and I'll leave it that way. But then again, if you look at the abnormalities and look at the cyber security issues with those, that may be a way to exploit your code and cause different things to occur that you don't know how. Because if I can interject that code into the system somehow that hasn't been used for 5 years, it may do things in your code that you don't want it to do anymore. So it's a question that you have to look at it very well when you go that way. Next topic is data flows. Now, data flows everywhere. What do I mean by that? We mean that it could go through the user input, through processing, to a data store, or other transaction output. It could go to a tape drive. The data store goes to the user displays. Data stores go to reports. It can generate another transaction to another application. I mean, we have linked applications together, so a lot of times we'll have a transaction flow going out from one application to another application. For instance, in us, a lot of times it's logistics applications generating financial transactions that go to the financial application. Likewise, the reverse. The financial application may be sending information around money that's available to a logistics application. So you've got to look at the transaction flows that occur. And remember, as you move things into a new environment, if I'm moving the system into a cloud environment, that transaction flow may still have to be maintained going back to another application that's sitting in the mainframe. So try to understand that, this thing's just going away. You can't move everything at once. And a lot of times you move pieces of it, but you have to understand when you move a piece that you may have to go back and forth with, information to the old pieces. Also, it's timing issues. You may do backups. Backups occur at different times. And so the backup may be coming out at a timed release cycle. Now, again, the application may not know that there's a backup occurring because mainly it may be a different application. I mean, so you have to look at what do you think is going to occur at some point in time. Is there a backup system out there somewhere? Is there a backup drive? Is there a backup database that's being filled that's not part of the application? It's just something that occurs by itself alone. Likewise with, is there any alerts that are occurring on the user display as part of the transaction flow? Because now you have another function that you have to program in as an alert that's occurring. And of course, any data flows that dead end, you need to know that too, because obviously something was there before, but it's no longer there now. In a lot of ways that you get around this, or we used to get around this, is if we get a warning coming up, an alert that comes up, we ignore the alert. That's the easiest way of killing a code structure, basically, and saying, I know it's going to alert, but I don't really care anymore, so it's an error. So you got to watch for those as well as you do the analysis of what's actually out there. Now let's talk about security. If you look at the current configuration in the mainframe, you have to look at what security model is actually being utilized. Now, we talk about authentication authorization, basically. You know, in the mainframe, you got different issues. A lot of times when you move it to a cloud structure and everything else, or wherever you're going to move it to, you're going to have different issues because of the vulnerabilities that are currently in the infrastructure, or it could appear in the infrastructure of the new configuration that you're using. So you got to think about what are the attack vectors that are going to occur, especially those that are regarding the data structures. Because a lot of times, the initial security model is basically make sure that I understand this person that's coming in. And then there's some other things too. Make sure I give this role to this person. Well, how do you determine the role? A lot of times that was a database lookup. Okay, that's really cool. However, in a new environment, that's probably not secure. So you got to figure out what is the unique qualities of that person and everything else. That's authentication. Make sure I know who that person is. And so as you move forward, you got to be careful of making sure that that's true and that's good out there. Next is authorization. What role should I give this person? Is it a database lookup? Who is managing that database? Is that database secure now? Is that database in a way that only the system admins can actually get to it in a way, and they've been authenticated into the system? These are the things we start to talk about as to how you go forward and figure out exactly what you need to do for security. Now, you remember, mainframes have certain issues with security. They kind of have preventions associated with it. A lot of it is because the code is so old, it's difficult to actually get into a mainframe and do things, except wipe out things in the mainframe. So the question is, if you look at the threat vectors that occur now, is what do I want to get out of you? I want to get your data. Usually that's the case. Your data is important to me. I can mess you up. I can have you denial of service by messing some of the calculations up. But, you know, I want your data. The second thing that we find as a good attack vector is to go and try to change some of your data. So if you change the data, I may cause different things to occur. For instance, in the logistics system, one of our favorite, I guess, is a good bad word, but one of the ways you can do this is changing the quantity of a particular part. If I believe that I have, 10 widgets out there that I can utilize and I really don't have any, when I go and order that widget, which says that I have 10 of, I never get it. And the system basically says, oh, I don't know what happened to this widget. Well, that may affect a mission or a business function that you have. So you got to look at how the attack vectors are going to occur in your system, and you have to mitigate those attack vectors. You may have to put in different security features that you didn't have before in your mainframe, such as, do I have to have a database firewall that prevents things from occurring for transaction-wise? Do I have to have other things in my system as well to determine what my transactions are and validate the transactions before they occur? And you got to be sure that you have enough information to do your security model, because this is the main efforts that occur, the problem spaces, is the security. As you move going forward, this is very important as you think about if you're going to rehost or you're going to migrate. The SaaS functions will have their own security models too, but you have to, again, look at them this way. What are you doing to ensure that nobody gets into our data in that SaaS model? What are you assuring that you're doing to ensure that only authorized people actually get things and that they're authenticated in such a way that we are sure that there's the people? So understand that that's some of the functions you're going to have to go work through when you actually figure out how you're going to move applications from a mainframe. Okay, result-wise, here's what you got. Map out your results, flowchart them or something, link controls to the business logic and overlay this to the data flow. If you think of this as a giant flowchart with things associated with it, it gets very large very quickly. So you got to figure out a way of actually doing this. You got to figure out how you're going to actually show anonymous flows that don't make that sense. or decide that you don't want those anymore. So you got to delete them from when you do the rehosting or the migration, or understand that they exist, and then they may be security flaws that you have to take care of and mitigate in some way. And then if you look at everything, look at overlay security on the whole package and say, guess what, this is what I think we're going to have. It's important to go and look at what you think are the risk vectors, the attack vectors that any enemy will use. And any enemy in the business sense is, other businesses, other governments, anything nowadays. Or it's a simple hacker that doesn't like you. That's always the case, that you have to think of it that way. And who can actually get into the system now, no matter where it is, where it's hosted or rehosted. So you got to look at those controls as well. Okay, we're going to talk about one actual use case. We've had a couple of use cases, but it's just one of these now, and we'll discuss this. Okay, this was the logistics system. It's on a Unisys mainframe. It has roughly 2 million lines of code. Well, all of a sudden you're saying 2 million lines of code. This is kind of bad. It's not like, 50,000 lines of code. I have 2 million lines of code. What am I going to do with 2 million lines of code? And I probably don't quite understand 2 million lines of code anyways. So I also have a custom user interface, of course. Why not? 700 plus screens. Okay, you may think that is a normal system for us, but that's not. 700 screens is about right for a 2 million line code COBOL program for us, because we have specialized it to death. And so we have specialized areas, specialized screens, and everything else associated with it. Of course, we have RDMS, we have index file structures, we have two databases, and 600 files. So this is what we call a very large system that you want to talk about moving. And the question becomes, okay, what am I going to do with this? Do I really want to look at software as a service? And we kind of done that in some areas, but we've burned and had some burning issues that occurred with one of the projects that we had already. So we don't necessarily want to bundle all our capabilities into one particular SaaS function, SaaS capability, because as we start bundling, we may do parts of it, but if we try to do the Big Bang theory of moving all logistics functions into one system, it's going to take too long, and therefore it's very messy and difficult to actually code, or in this case, reconfigure for the SaaS. So if you look at this, we had approximately 70% of the funding was for mainframe expenditures. Now, obviously, this is a expensive system to actually run, but again, it works. It meets mission requirements, so you got to think of it that way. So you got to convert. Talk to the SMEs and say, hey, guess what? I think that, we need to do something about this. All right. Okay. Basically, we decided, okay, let's rehost this. Let's move as much as possible to a mainframe, not to a mainframe, to a commercial cloud environment, and figure out how can we actually, change things as we want to and go forward with it. This is probably the best approach for this one. 2 million lines of code to redo the entire would take a very long period of time. This effort took about 13 months to complete, just moving things, changing things accordingly, because you have to change some things. You just can't do everything by itself. And you have to move it to what is supported in the cloud, what database is actually there, as opposed to what we currently have. So that's been pretty well. The second phase is to extend it to predictive maintenance and analytics. So we decided, okay, this is kind of cool. We kind of now move it to a cloud. Now, what else can we do with this? What added functionalities can we get? Because now we're in a virtualized environment where we could do more things with it. And this would be a typical use case. I mean, I haven't put another one in where we actually did a total conversion into C++. It was a very small system. It was fairly easy to understand, but it took almost the same amount of time. Just because it's the way that you have to do. You have to do all the business logic. You have to translate this into COBOL, from COBOL into, C++. Then you have to figure out how this actually interfaces with each other, and the data flows and the control flows was a big deal. And so it took a long time to actually figure out everything and make it work. So you have your choice. And, it's a question of how complex is the particular system that you're trying to move from a mainframe into another environment. Which leads us to the last slide, a decision. So you have to make a decision at some point. Again, what is it? Do I push everything into software as a service? Do I rehost or migrate? Or do I get rid of it? Now, depending on what you're doing, you have to decide. If you rehost migrate, you probably save some money by decreasing your manpower, mainframe costs. Also, particularly maybe software as a service, you also decrease your cost, because again, sometimes you're doing it because you don't want to recode or you don't want to host it for yourself. So you have to understand there's a cost structure followed this. But then again, there's also a function of getting the culture involved into determining what it's going to be. You got to consider the size, complexity, customization. It's all going to affect what you're going to do and what you're going to do as part of your decision base. And you also talk about timing. Do I need this tomorrow? Is my mainframe going away? Is my mainframe old and I can't maintain it anymore? If it is, then you have to make a real quick decision, but it could be either rehost or SaaS at that point in time. That's what you have to decide. And when you do this, if you rehost or migrate, you have to look for the anomalous objects. You have to plan risks. You have to plan for using approved constant open source capabilities that are existing in the new environment. If you don't, then you're probably going to be moving old stuff over that's not going to be maintainable as you go forward. So you got to think of that. And you have to determine, further if the application needs to be FISCAM audit ready and RMF ready for fielding. This is a big deal. If it's a business function financial application, for instance, it has to be FISCAM audit ready. So you have to make sure that you are going to go through and look at the various control features that actually support FISCAM. And basically it's some things like CM controls, as well as ensuring that your ICAM, your identity management capability exists and how you're tracking it accordingly, as well as what security controls you're implementing. So if you have an incident, how you manage that incident. And the same with RMF. If you're a government agency that needs RMF controls and you have to do it, you should be looking at going forward as this is what you need to do to move it into that environment and keep it going. And I think that's all I have for today. So back to you, John.
Well, thank you, Frank, for a great presentation. And we're not going to pause. We're going to keep moving. And next up is Danette Bayman.
Thanks, John. Thanks, Frank. So for those of you who aren't aware of the recent happenings here at Micro Focus, with the acquisition of HPE Software, Micro Focus is now one of the top 10 largest pure-play software companies in the world. We believe the combined HPE Software and Micro Focus Better Together portfolio allows us to solve our customers' needs across the hybrid IT landscape. We're the market leader in distributed COBOL, reinvesting $60 million annually into our COBOL R&D. And out of the Fortune 500 companies and the federal agencies that are out there today, 90% of those companies run on Micro Focus COBOL. These 4 strategic focus areas are what our customers have told us matter to them the most for their business. We can discuss how we integrate agile development between mainframe and distributed to enable faster, more efficient, parallel development and delivery of innovation to improve your experiences. Our solutions eliminate mainframe development test bottlenecks and costly infrastructure. Our approach is the fastest, most secure, and lowest risk process. Take your legacy applications to the cloud, native applications, leveraging predictive analytics and machine learning to enable AI. Micro Focus can scale capacity for your mainframe applications in the cloud while enabling cost savings that completely fund your legacy modernizations and enterprise-wide innovations. We do all this while helping you maintain enterprise mission-critical security and HSPD 12 mandates. Micro Focus solutions are the standard for identity and access security for over 2 million DoD desktops through the DISA MIAP portal. Okay, so let's talk a little bit about what mainframe modernization or a mainframe makeover is. Frank just discussed a lot of that, and he said you need to make a decision. Do you rehost, do you rewrite, or do you do nothing? Well, our approach is to rehost, if that makes sense. The drive towards mainframe modernization requires a strategy that enables adaptability to change while you're managing your costs and your risks. We can do that with rehosting. Micro Focus allows you to extend or replace your mainframe with low-cost, high-scalable cloud capacity and modern architectures and tooling. Modernization is about how we can make mainframe development more agile, how we can introduce application analysis to identify impact analysis and coding standards for your mainframe applications. In fact, Frank mentioned some of those when he said, how can we map our code to the business functions, get screen flows, data flows, JCL flows, and he mentioned branches that may not be executable. To me, that's dead code. Use an application analytical tool to help you find these things. Know what you have on your mainframe. Even if you're just going to do nothing, at least know what you've got on your mainframe and how the parts fit together. You can use modern development tools that utilize the standard IDEs like Visual Studio and Eclipse to improve the efficiency and make it easier for any new developers that you may have coming into your business. Allow them to use new tools that they're familiar with, the IDEs that are out there now. Extend your COBOL application code or experience via microservices, such as .NET or Java, with local desktop compiles and testing for faster feedback. We like to say COBOL is a .NET language. Have your C# compile your COBOL code as managed code and have C# screens call those, or Java screens call that old COBOL legacy code. And what about accelerating test cycles through unit test frameworks, continuous integration, and removing the dependency on mainframe test resources, and by integrating mainframe tooling into agile planning and configuration? You may say Azure can become your new mainframe. Take advantage of the latest technology that's out there today while leveraging your decades of business logic and your data logic. I'm sorry, I forgot to advance the screen. One of the chief benefits of modernization approach is that the savings can be completely fund the modernization of your legacy applications by replacing the costly mainframe MIPS with low-cost commodity cloud capacities. Gardner says a MIP costs anywhere between $3,000 and $4,000 per MIPS. Why not replace that with something that's cheaper? Developers can develop, compile, debug, and test their COBOL or PL1 applications in a Windows-based environment. There's no conflicts, there's no wait time, there's no resource contention, and you can be achieving increase in your productivity and quality. A fast development lifecycle is often hampered at later stages by limited access to mainframe resources to conduct that testing. To shorten mainframe test cycles, we can produce a Windows-based environment test harness. That can be deployed on-premise or in the cloud. It produces a flexible mainframe application testing environment that can be created on demand and scaled up to increase test capacities without consuming additional resources on the mainframe. Faster access to test environments means quick feedback to developers and shorter release cycles. The flexibility to deploy mainframe workloads onto alternative platforms provides a flexible, platform-agnostic COBOL and PL1 application production environment, allowing you to deploy mainframe applications onto Linux, Unix, Windows, containers, and the cloud with minimal change. Frank was talking about the U.S. Air Force and some of the things that they did. When they were looking at mainframe modernization, well, one of the most common questions we're asked when customers start to consider rehosting mainframe applications to another platform is, where have we done it before? And Frank mentioned some things with the Air Force. So when they were looking at a mainframe modernization, they considered automated code conversion to refactor their COBOL. But upon further investigation, it was determined that that may render the code unmaintainable and may not perform to their satisfaction. They evaluated other options, and they chose a partner that had proven cloud application migration processes that leveraged best practices with Micro Focus and Microsoft. They wanted an environment that enabled parallel development and repeatable automated testing. They estimate that with the Azure infrastructure, Micro Focus tools, and the Astadia Azure mainframe replatform process, about a 90% reduction in IT costs and an ROI of 5 months. Over the past 40 years, we've helped over 1,000 customers worldwide get off their mainframe with cost savings from 60 to 90%. We look forward to helping you on your journey to similar results. Here are some details where you can find more information to help with our modernization journey or your modernization journey. Please feel free to contact myself or Jeff for any further information or questions. And thanks so much for your time to become familiar with what we have to offer. John?
Well, thank you, Danette. Great presentation. I appreciate it. I'd like to quickly remind everyone that there's still time to submit questions if you would like to do so. Just look for the question field to the left side, to the left of the slide window. Type in your question there and click on Submit. And also, you can download a copy of today's presentation. Look for the Resource Center just below the question field. And at this point, we will turn to questions from the audience. Bear with me, see what came into the queue here. Okay. We'll start with this one. I think everyone knows that there's a shrinking workforce of IT experts trained in the operation of legacy mainframe systems. A lot of the people who had that expertise are no longer in the workforce. But at the same time, there's a shortage of skilled IT workers who have the capability of operating advanced systems. So the question is, to what extent does mainframe modernization alleviate the shortage of skilled IT workers on one side or the other of that equation, or does it have much of an impact? Is that something that people should consider when they're trying to make a determination on how to go forward? And that's for either speaker to take a crack at.
This is Frank. I'll try. The problem is that, there's few people who understand mainframes now more than people who understand, new advanced technologies and everything else. The schools are teaching, everything else sophisticated and going forward with. So if you want to have a workforce, you're going to have to understand that the workforce that's being educated, the new workforce is being educated in new techniques and systems. So I think that and the problem is that we do have a shrinking mainframe force that understands COBOL and everything else. So I believe that, the faster you get off some of this, the better you're going to be, especially when you want to add new capabilities to your system. Because if you don't understand, the new capabilities, it's going to be hard to code within it. So I think that, you have shortages either way, but I think that the shortages are getting worse and worse on the mainframe side, and so you have to advance, and the training is on the other side.
I also think that with the mainframe workers that are still out there today, that once they see some of these modern tools and how they can become more efficient using those tools, get things done faster with less errors, it makes a good a point for getting them onto these modern IDs that maybe younger people know.
Sure. Now, I think the point was made during one or maybe both presentations that cultural considerations almost always come to play when there's a new program is brought online or at any stage of a modernization program. Can you speak to some of the keys that help to make or to be successful in navigating change management during a mainframe modernization program? Or is that something that people should factor in when they're trying to decide which way to go?
Well, I think you have to factor it into which way you want to go, because your workforce is very important to you. And so the question becomes, how can you involve your workforce in coming out with a new solution? And that's basically what you have to do. You have to get them to the point of saying, yeah, I understand where we're going to go, and yeah, I'm going to participate in it, and I'm going to make it, the new system is going to work just as well or better than the old system. And it's a question of culture. A lot of people just don't want to change, but it's a way of bringing them into the fold and saying, hey, this may work, for you. And, it's a question of understanding, what they want to do in the future and what their motivation is. So if you motivate them by saying, we really need you to help us do this, it's better than saying, well, we're just going to do this and we're going to ignore you and we're going to come out with a new system and we don't care. Because that's not going to get you anywhere with the culture nor with the current support that you're going to need to actually do the migration.
Okay. Anything to add to that, Danette?
No, I agree completely.
Okay. This question just came in. It's a little more technical. The listener asks about, what about environments beyond COBOL, PL1, Fortran, and there are many others? Can you speak to that issue when you're going down this road and you're dealing with something other than COBOL?
Sure. Well, Micro Focus is in the COBOL business, but for modernization, we know that there are many shops out there that are .NET shops and Java shops, for that matter of fact. And how do we modernize that COBOL while still using those languages to interact with that old legacy COBOL? And by having the ability to compile with managed COBOL in a .NET environment or into Java bytecode, we can kind of bridge the gap between the old and the new.
Okay.
In as far as languages go, Micro Focus does support mainframe COBOL and mainframe PL1 in a real environment.
Okay. Here's a question about security, and I think security is top of mind for just about everyone in the IT world these days. Can't open the paper without reading a story about a new threat or a security breach. What are the security implications that need to be considered when you're talking about mainframe modernization or mainframe makeover, to use the terminology of the title of this webcast?
Well, Frank touched on a number of things that needed to be taken into consideration. From my point of view, it's what do you have on the mainframe now? Is it on an IBM mainframe? Is it top secret or ACF2 or RACF that are using security now? What are the profiles associated with those security products? Who has access to what systems and what data sets? That all has to be considered when migrating that to a new platform. If I have access to particular CICS systems and someone else does not, how do we incorporate that so it maintains the same integrity that it had on the mainframe? So we take all that into consideration.
Mm-hmm. Mm-hmm. Frank, you spoke to this during your presentation. Do you want to add anything at this point?
Well, I agree. I mean, you have to look at the security implications of what you had and what you want to go to, because there's lots of things different than what you used to do right now. So the security model that you're currently using for access is very important to analyze and to figure out what you can do in the new environment that you can't really do based on the old environment, especially when you're using other subroutine calls and everything else. And Danette is right. Some tools that we used to have in the mainframe environment no longer are maintained by anybody. So the question becomes, how are you going to change those tool sets into something that's more modern and more capable of working in the virtualized environment?
Sure. So we all know that just keeping legacy systems running is a very expensive proposition, and that one of the enticing things about modernization or makeover is cost savings, which you talked about. And then there are also costs associated with not taking action. So if you're trying to make a decision on what to do and then also when to do it, and the financial piece has to be a big part of that calculus, how do you get your head around that? I mean, that's too big of a question to get a thorough answer on here, but how would you advise people to think about it?
Well, I think, financially it's always a big deal. The question becomes, in terms of maintenance, how much money are you actually spending on maintenance in the old system as opposed to the new system? Because there's going to be some cost for the conversion, no matter what it is, rehosting or total migration. And so you got to push that into the way of doing this, because the issue becomes, okay, and you got to determine what you want to, why you want to migrate. That's the other question. If you're migrating because you're going to lose the mainframe, well, that's just an immediate need that you have to push out. If it's because you want to save money, well, then you got to do the dollar cents of what it costs me to maintain as opposed to what it's going to cost me to maintain in the future, and looking at the migration costs and determining when a break-even point is going to occur in the future. If it's to do resiliency and you're more concerned about resiliency and advanced security, then you may want to migrate anyways, because if your business depends upon resiliency and to keep it go forward, then you have to get off that mainframe if that's one of the issues that you have with the current mainframe. So it's a lot of questions you have to ask, and you have to put it all together and figure out what is the best course of action for my business or my mission in terms of resiliency and then in terms of dollars.
Okay. Now, this may have been answered during one of the presentations, but what would be the based on the experience you all have, what would be the first 1, 2, or 3 things that you would advise an agency to consider at the outset to give themselves the best odds of embarking on and completing a successful mainframe modernization project?
Oh, well, Frank touched on that earlier, too, when he said you must have your subject matter experts involved.
Sure.
And in fact, Microfocus goes out and discusses this with clients. After our a few initial meetings, we have what we call a level 1 questionnaire that we ask customers to fill out for us. And it's a very long, involved questionnaire, but it does give us an idea of what you had on your mainframe. I mean, you need to know everything. It's not just the security piece of it. What about all those third-party vendors that you have that's doing your scheduling or your output management or your monitoring? You still want that in your replatformed environment. So we'll meet with them and request that they're usually a 2-day assessment with their subject matter experts to go over absolutely everything in detail on what they have on the mainframe and how that would map into a rehost environment.
Okay. I think we're going to have to stop right there. That's all the time we have for today. I would like to thank Frank Konechny and Danette Bayman for their informative sessions and insights. And
John?
Yes.
There is one out here. I did want to just quickly answer it. It says, why was Azure targeted over AWS? And the answer is it wasn't. We are cloud. Azure is what the U.S. Air Force used in the example that I showed, but we are cloud agnostic. We don't care who the cloud provider is. It's based on around any IaaS cloud provider out there.
Great. Well, thanks, Annette, for clarifying that. I appreciate it. You probably answered the question that a lot of people had. Thank you for jumping in. I'd also like to thank MX Group for sponsoring today's webcast. And as noted earlier, in the next day or two, you'll receive an email with a link to an archived version of the session. Review it or share it with a colleague. Thank you all for attending, and this concludes today's webcast.